Hey everyone, welcome back. We often hear about the golden rule of database design, which is normalization. It's the process of organizing our data to minimize the redundancy and ensure data integrity. Typically, by breaking data into multiple related tables, so each piece of information is stored only once. It's a fantastic for consistency and clean data management. But what if I told you that sometimes to achieve incredible read performance, we intentionally break this rule? Today, we are exploring I would say the rebellious but often necessary technique of denormalization. This is the opposite approach of intentionally introducing redundancy by combining data into fewer tables, all to speed up read operations and slash the need for complex slow joins. Okay. First, let's just try to understand what is the differences between normalization and denormalization. So let's take this example. In a normalized system, imagine that you have two tables. We have let's see here. We have a member table and we have a visit table. And when you want to, for example, when you want to retrieve a visit object that belongs to a specific member, you will have to perform a join operation between these two tables. This keeps data clean and avoids redundancy. And if you can see here, the members table is stored only once, and the visit table is stored only once. In the other word, denormalization is quite different. So if we want to consider the denormalized approach, instead of joining those tables every single time you need to fetch an order and visit with a specific member, you might decide to store some customer details like I would say what we did here. For example, we have the email. I don't know what we we should put the full table. Yeah, the if name, for example, or maybe like the member's email. Yeah, the member's email, for example, and we put all the data between from these two tables to one big table, as you can see here. Um, so this means that I would say each visit record now contains a copy of the necessary member information. This immediate benefit when you fetch and visit, for example, and visit. This is we call this visit. So yeah, and when you fetch it, for example, and visit, it becomes way more faster than you think. It becomes way more faster because we don't have to use any joins operation anymore. Okay, so yeah, you understand what is the difference between normalization and denormalization. Basically, if we have two tables, we just put all the data into one table to make the read operations quite faster. But is it that's it? Is it only that? I guess we need to understand why denormalization is a quite good approach. Why should we consider it? So why would we willingly duplicate data and potentially risk inconsistencies? Because actually we're duplicating data. So denormalization is often considered and strategically applied in scenarios where, first, performance is absolutely critical. Two, when your application must have very fast read operations. Three, especially in high traffic environments like popular websites or real-time systems, denormalization can be a game changer. Okay, so the second, we have joins become a major bottleneck. Like in complex queries, particularly those involving joining multiple large normalized tables, these join operations themselves can become significant performance bottlenecks. Denormalization aims to eliminate or reduce these costly joins. Number three, we have data is read mostly. Okay, so if the data is question is if the data in question is frequently read but rarely updated, or perhaps updated in bulk during off-peak hours, then the overhead of maintaining redundant data might be an acceptable trade-off for the read performance gains. If data it doesn't change often, the risk of consistency is quite lower. Okay, what are the challenges of denormalization? The first thing we will talk about, which is data redundancy. This is the most obvious consequences. I guess duplicating data means that the exact same piece of information is stored in multiple places across your database. This leads to directly to increased storage requirements. Like you will naturally need more disk space because data is being stored multiple times, while storage is relatively cheap. This can add up for very large data sets. And number two, we have data inconsistency risks. This is the big one. When an update occurs to a piece of data, like a customer changing their email address, for example, ensuring that all copies of that data across all denormalized tables are synchronized becomes a major challenge. If updates aren't propagated correctly, you will end up with conflicting or outdated information, which can be disasters. Also, we have a problem in complexity in database or complexity in updates. So in perfectly normalized schema, updating a piece of data in one table automatically reflects the change across all related operations due to joins. With denormalization, you might have to explicitly update multiple tables or records to keep the duplicated data consistent. This adds complexity to your write logic. Number three, we have maintenance overhead. The application logic often needs extra care and complexity to handle the synchronization of the redundant data. This can be quite complicated. This can complicate the development process and make long-term maintenance more challenging. You are essentially shifting complexity from read operations, which is joins, to write operations, which is to ensure consistency. Okay, right now we know what is denormalization. We know why it is important. We know the challenges. We need to know we need to know now when should we consider using denormalization. So you can use denormalization first in reporting systems and dashboards. Like systems that generate complex reports often need to aggregate and process large volumes of data very quickly. Denormalized data structures where data is pre-joined or pre-aggregated can make these reports generation queries run much faster. Number two, in caching layers and high traffic web applications. Web applications that need to serve content extremely quickly, think social media feeds, popular product catalogs, or news sites, can significantly benefit from having a pre-joined or pre-computed data stored in denormalized formats. Perhaps even in a dedicated caching layer like Redis or Memcache. This minimizes database load over for frequent reads. Number three, we have data warehouse and business intelligence. In the world of analytics and business intelligence, denormalized schemas like star schemas or snowflake schemas are very common. These are designed especially to simplify and speed up the complex analytic queries that data analysts and the BI tools run. Making it easier to slice and dice large historical datasets. Okay, so let's talk about some best practices that we need to follow. We say first you need to identify critical path and bottlenecks, like only denormalize the specific parts of your data sets that are causing genuine performance bottlenecks for your critical read operations using profiling tools to identify these areas. Number two, selective duplication. Instead of denormalizing entire database or schema, consider duplicating only the most frequent access and performance critical piece of data. For example, just the customer's name, not their entire profile, for example. Number three, use triggers and stored procedures. To help maintain consistency, you can use database triggers or application level logic to automatically propagate changes across redundant data whenever an update occurs to the source data. Number four, batch. This is number four. batch update for infrequent changes. Like if the denormalized data changes infrequently, consider using batch processes that run during off-peak hours to update the and synchronize the denormalized copies. Number 5, regular audits and consistency checks. Periodically run checks for audits to ensure that denormalized data remains consistent with its original normalized source as well. Yeah, this helps catch and any synchronization issues early. Lastly, consider versioning. For some type of denormalized data, implementing version control mechanism can help track changes and allow you to roll back if inconsistencies are introduced. Okay, I guess we can go to our conclusion right now. So yeah, denormalization is undeniably a powerful tool in systems designers' toolkit, especially when raw read performance and speed are paramount for your application success. By strategically duplicate data, you can simplify queries, eliminate costly joins, and significantly boost read performance, making your system feel much more responsive to users. However, it's crucial to remember that this power comes with significant trade-offs, primarily increased storage requirements and very real challenge of maintaining data consistency. These require careful handling and robust application logic. When considering denormalization, always think about these challenges. So yeah, that's it. This videos for this video, and if you like this video, give it a thumbs up and hit the notification bell so never miss any video. And see you for a new video.